Hi everyone, this is Viktor Naroditsky from OneTick. Today I bring you a hidden gem, onetick-py. onetick-py is a Python library designed to make tick data analytics easy and amazingly efficient. onetick-py is built on top of OneTick, a tick management platform that's been in use by the largest financial institutions for close to 2 decades. A beauty of onetick-py is that it does not require learning a new domain-specific language. Instead, it resembles pandas so closely that much of it will feel familiar. In the next 10 minutes, we're going to implement a golden cross strategy in onetick-py. Then we'll find the prevailing quote at the time of each trade. We'll use that information to find outlier trades, and then we'll apply the analytics to 1000 symbols. Let's get started. The first line is to import this library. We import in onetick-py as OTP, and then we're going to look at some data. We'll look at trades from the trades and quotes dataset distributed by New York Stock Exchange. Let's execute this, and then we'll just want to see the trades. So for that, we need to specify the time interval, and we'll be looking at 1 hour between 10 a.m. and 11 a.m. on the 31st of March, and we'll look at Amazon trades. Whenever you see otp.run, it means that we are sending the query. In this case, it's very simple. It's just a select all to the servers, and the infrastructure could be scalable and cloud-based, and only the result is returned into Python, and it's returned as a pandas data frame. So here we are. We got the trades. There are 71,804 trades. Let's make a note of this number. And there are quite a few fields. We probably won't need all of them. Actually, below we'll just use price, condition, and exchange fields. So we can limit attention to just them, and we do it the same way we would do it in pandas. Let's execute this code, and we get the same number of trades, but just the fields we're interested in. Next, we're going to compute a moving cross strategy. So for that, we're going to need aggregations, and we're going to use the .ag method that takes a dictionary as an input. The key is the field name that will be created, and the value is the aggregation we're going to apply. So let's apply the mean aggregation to the values of the price fields. If we execute this, we'll just get one number. So that's the average price between 10 a.m. and 11 a.m. We'll want something slightly different. We'll want a sliding window of a certain length. So let's make that 60 seconds. And now we have the value for every minute between 10 and 11 a.m. But we also would want this to be sliding. And for that, we're going to turn on the running flag. So this returns the value of the average for the sliding window of 60 seconds. And finally, we'll need to compute another moving average after that, and for that we'll need all of the original fields. So we can turn on the all fields flag to true. And now we have all of the original trades, so price, condition, and exchange, along with this average value that's computed in the last 60 seconds, including the current trade. And so we have the same number of trades as we originally had. Let's call this the short-term moving average. And symmetrically, we're going to compute a long-term moving average, but we'll make the sliding window longer. So we'll make it 5 minutes. And now we have short and long. And now we're ready to define the signals. We're defining the signals in these two lines. A signal to buy is when in the previous tick, and we can refer to previous tick using negative indexing, the short-term moving average was below the long-term moving average, but in the current tick, it is above. And symmetrically, we define the sell signal. Let's run this. And we saved the output into a variable called def. And now every tick here has a buy and sell flag. That's 0, but sometimes it's 1. So let's take a look now just in pandas, not in onetick-py anymore, at the last 5 signals. And make a note that the last signal is buy around index 68,000. Let's plot the signals. The short-term signal is the one that moves around more, so that's the blue one. And we can see indeed that at the end it's above the long term, so the last signal was buy, and it was around 68,000. Next, we're going to look at something slightly more complex. We're going to look at two data sources, at trades and quotes. Let's just take a look at what quotes look like. And we're going to look at the national best bid offer. And we'll just look at bid price and ask price. And we'll make a copy of the timestamp into the field called quote time. And we're using the same 1 hour time interval for Amazon. And there are quite a few more updates to the NBBO. Then there are trades, so there are close to 800,000 quote updates. Next, what we're going to do is for every trade, we're going to find what was the prevailing quote at the time of the trade. So we're going to use the quotes that we just looked at. We're going to use trades that we looked at before, and we'll combine them using a native OneTick function called join by time. That takes a list of arguments, and the first argument is a time series that is the leading source that will be enhanced using information from the other time series, so from quotes in this case. And the enhancement takes the tick from the non-leading sources that's as close to the current timestamp as possible, but precedes it. So now every trade, and here the number of records is the same as the number of trades, is enhanced with bid price and ask price from the quote where the timestamp precedes the timestamp of the trade, but is as close to it as possible. In this particular case, this timestamp is a few microseconds before the timestamp of the trade. Let's now use this information to look at cases when trades somehow occur outside of the spread. We'll define a distance to be 5 cents, and we'll be doing this filtering that's done in a manner very similar to pandas. We are saying that we are looking for trades where price is either above the ask price plus 5 cents or below the bid price minus 5 cents. And let's run this code. We get the result. And we notice something peculiar. Exchange seems to always be D, and D corresponds to off-exchange trades. So what we're going to do is we're going to do some filtering, but not on the exchange, but rather on the condition. So we're going to limit trades to only continuous trading on exchange trades. And for that, we may want to refer to the list of condition codes, and we're going to filter out conditions like market center opening trade, market center closing trade, and so on. We're going to do this using a filter again, and the condition is a string field of up to 4 characters. So we're going to use a regular expression match to make sure none of the condition codes that appear here is present in the trade conditions. Let's run this code. And actually for Amazon, we get no trades. But let's now look at more symbols. We can find a list of symbols that start with the letter A by using the otp.symbols command. And there are 990 symbols that start with the letter A. So let's now apply the same code, but to all of the symbols that start with the letter A. And that's as simple as changing the symbols value here to this query OTP symbols that looks up all of the noisy text symbols starting with the letter A. Let's run this. And what we get is a separate time series for every symbol. So every of those 990 symbols. Most of them are empty, but some of them are not empty. This is not very easy to digest. So we're going to represent this data a little bit differently. We're going to merge the data in OneTick before we return it. So we're going to call otp.merge function, and we'll merge all of the symbols. And then when we call otp.run method, we don't need to specify the symbols anymore. So let's run this. And what we get is 280 trades where the trade occurred outside of the bid-ask spread. So for example, 86.98 is more than 5 cents above the ask price of 86.90. So let's recap what we've done here. We found the prevailing quote at the time of each trade. We did some filtering on the trade conditions. And we applied that to 990 symbols. And all of that was done virtually instantaneously. And all of that happened on the back end, where we processed tens of millions of ticks in order to accomplish this. So hopefully this gives you a sense of what OneTick-py is capable of. And let us know if you'd like to learn more. Thank you.